Hi everybody, it's Mrs. Harbin. Welcome to Video Notes 1.2. One big objective we're going to learn here, but there's a lot of parts to it. So we're going to get through this and practice in class. Get ready. Little Might Be Giants element song there. All right. Please, please, please use Chapter 2 to help you with this. This video will do some help with definitions, but please make sure that you use your book also, Chapter 2, Sections 1 through 4, to help with this. All right. So, classifying matter. Look at all of these pictures. When we think about matter, we have to know the building blocks of matter, and that's atoms. So, atoms are the building blocks of matter. Building blocks. We talked about their parts. Okay. They make up everything. And elements are made of atoms. Okay, and then elements combine to make compounds, and those compounds are made of molecules. But atoms are what make up everything. Okay, so these are individual atoms. These are bonded atoms. But all elements have unique atoms. Okay, molecules are bonded atoms. Bonded. So instead of being individual atoms, molecules have a chemical bond that holds them together. So these are molecules. These are molecules. These are molecules because there's a chemical bond holding them together. A pure substance is the same composition. Oh, look at this. Composition all the way through. All the way through. So each part of a pure substance is exactly the same as each other part of a pure substance. So make sure to know that a pure substance has the same composition all the way through. All right. So what's a pure substance here? Well, these are three particles that are exactly the same all the way through the sample I circled. So that's a pure substance. All right. This is a sample of a pure substance because each part is exactly the same as each other part. Okay. This, if we put it all together, is not a pure substance because this part is different than that part. Okay. This is not a pure substance because these parts are different than those parts. Okay. So, compounds are pure substances that are made of pure substances made of different elements bonded together. Different elements. Chemically bonded. Chemically bonded. Okay, so a compound has to have more than one kind of element in it. There has to be a chemical bond between at least two elements in order to make a compound. But compounds are pure substances. So let's see if we have an example here. If we look at this, we see this is one kind of element, this is another kind of element, this is a chemical bond. So this represents a compound because each piece of it is exactly the same, so it's a pure substance. But the kinds of elements in that pure substance are chemically bonded. Okay? An element is also a pure substance. Pure substance made of one kind of atom. One kind of atom. Alright, so if you look here, that must be an element because this and this and this are all the same kinds of atoms. Alright, if I looked at this part right here, this would be a pure substance because even though they're bonded together, this atom, and this atom are the same. So this is an element because all the atoms are the same. This is an element because all the atoms are the same. Mixture is a physical blend of more than one element or compound. How can that be? Well, if I take this whole thing, I see these kind of parts and those kind of parts. All right, these molecules have their own identity. They're going to have their own properties. these atoms are going to have their own identity. But if they're all in the same place together, then this is a mixture because some parts have a different identity than other parts. Usually for a mixture, there's like a list of ingredients, and each ingredient keeps its own identity. So there are two kinds of mixtures. There are homogeneous mixtures, which are very well mixed. Well mixed. Whoops. Who spelled mixed like that? Well mixed. Best example is a solution. All right. And I'll tell you that more about that on the next slide. Heterogeneous mixture is a blend of elements or compounds, or both elements, compounds, or two kinds of compounds, two kinds of elements. Not well mixed. Not well mixed. Okay, we'll look at some examples. So trying to help you get these definitions, I'm giving you what it might look like on a molecular level. Okay, so looking at these, molecule or element or atom, let's talk about it. Well, if it's something individual, boom, it's an atom. Okay, if it's things bonded together, it's a molecule. Okay, so we have one example of atom, and we have a molecule over here, bonded, molecule, bond, molecule. And more than one atom bonded together is a molecule. Bond. There are three kinds of atoms, but this whole thing is bonded together, so it's a molecule. All right, over here we have molecule and molecule. Okay, so two kinds of molecules here. Now that's a different question than element or compound. This is one kind of atom all the way through, that's atom. So this must be an element. These are molecules, but it's two kinds of atoms, so this is a compound. Okay. This is a molecule, but it's also an element because all of those atoms are the same. Same. Red. Okay. This is a molecule, that's a compound, because these kind of atoms are different than those, are different than those. So there's different elements bonded together, which makes it a compound. This part of this is element, right? But this part is compound. Right? But all of these are molecules. Okay, molecules. Alright, so pure substance or mixture. Well, if we back up to the other slide, you'll see that there are two kinds of pure substances, elements or compounds. And mixtures are blends of elements and compounds. So let's look at this one. And we see we have this kind of part, and there's three of them, and we have this kind of part, and there's two of them. So inside this container, we have two kinds of things. It's not all of the same things all the way through. So this is going to be a mixture. Right? If we look in this container, we have this part, this part, this part, and this part. But guess what? Every single part of this is exactly the same. So this is a pure substance. A pure substance or mixture. Well, here's one way to tell a pure substance or mixture. The physical properties. Let me look at what I have next. Physical properties for mixture. Each part of a mixture keeps its identity, keeps its own properties. Okay. In an element or compound, same props all the way through. All right, what does that mean? Okay, well, let's take an example. Salt water. All right, if you take salt water and you drink it, you can taste the water part of it, you could taste the salt part of it, but it's all mixed together. Okay, but each part of that keeps its own identity. So salt water is a mixture. Oh, wait a second, my pen went away. Mixture. Okay, salt tastes salty. Salt has props of its own. Water has props of its own. Each of them keep their own props, but they're mixed together. So that's why it's a mixture. Table salt, on the other hand, if you have table salt, every part of table salt, each part of table salt, each piece, of table salt. Has the same properties. Has same props. Okay. Water. Each part of water has same props. Same props. Alright. Oxygen. Each part of oxygen has same props. Alright, so what does that mean? Okay, so table salt is also known as NaCl. But you don't have properties of sodium and chlorine, you have just the properties of the whole thing, sodium chloride. Water is H2O. But you don't have properties of oxygen, because that's a gas, and you don't have properties of hydrogen, because that's a gas. You have properties of this new thing called water. But every piece of water is H2O. Right? Oxygen is an element, and every part of oxygen, if you have a tank of oxygen, is all oxygen all day. Okay, and those properties are different than the properties of the oxygen from the water, because the water and oxygen are chemically bonded. The hydrogen and oxygen are chemically bonded to make water. So then all of the H2O are unique properties. All of the NaCl are unique properties. And then oxygen only has the properties of oxygen. Okay, microscopic versus macroscopic. Micro is small, 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 small. So macroscopic is what we see. Microscopic is what we would see if we could see. All right. Even with the microscope, you can't see atoms, but except if you have electron tunneling microscope. So a lot of times we just use models for this. But if you see ketchup, you can't really tell what it might be. Okay? But you know there's a list of ingredients for ketchup. If we went down and made it smaller, 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 on the microscopic level, you might see some of this, some of this, some of this. So there's lots of different things in here, lots of different ingredients. Each ingredient keeps its own identity. And it's not super well mixed, okay? There's a little more of the little things over here and a little more of some bigger things over there, okay? So that's what makes ketchup a mixture, and each part of ketchup has its own identity. This is oxygen, right? What you see is this big tank of stuff, and you can't even see it. It's a gas in there, right? But if you could look at the small level, okay? Small level, small is micro. You might see this, 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 and this. And notice everything is exactly the same. And it's two atoms of oxygen bonded together all the way through. Sugar. We love sugar. Right? Sugar. This is what you see. But if you could look at what the molecules look like, this one, this one, this one, they're all exactly the same all the way through. Okay. Homogeneous or heterogeneous. This only applies to mixtures. Only for mixtures. All right. Okay, so here's a mixture. There's so this is kind of like Kool-Aid, all right? We'll just say it's like an orange drink. Orange drink. So if you could see this, orange drink is so well mixed that if we drank half of it, we would get exact same proportions. It might be 40% H2O. I'll put it up here. Like maybe it's 40% H2O. No, it's probably more like 90% H2O and 8% orange flavor and 2% sugar. Okay, so it's all blended so well that no matter what you get, you're getting these proportions in there. So this is homogeneous. I don't know how that works. This is homogeneous. All right, and it's a solution. Homogeneous solutions are the best and probably only kinds of homogeneous mixture. All right, look at this. This is a mixture. I see that part, that part. We got some rice, we got some beans. All right, if I take a spoonful of that, I'm not going to get the same number of rice as I get beans as I get these things. Okay, so this is a heterogeneous mixture. Heterogeneous mixture. Okay, I've been talking a long time, but we're almost done. What happens to molecules in chemical and physical changes? So these are molecules, right? And these are actually compounds because these atoms are different than those atoms, but together they make up water molecules. You do a chemical change, and you can get hydrogen atoms and oxygen atoms back from those molecules, okay? But the only way you can separate a compound is to do a chemical change. Physical change. Here's water. Here's ice, here's water, and here's water vapor in the air. But if you look at this, you still have H2Os. H2O, H2O, H2O. So H2O is going to be solid, liquid, or gas all the way through. It's H2O. This is physical. You can change the state. You can melt it. You can boil it. Chemical changes its identity. Changes identity. Okay, that's important for helping you decide if something's elements, compounds, mixtures. Okay, so to review, let's play some music and review. Elements and compounds are pure substances. Mixtures are physical blends of elements, compounds, and other mixtures. Compounds are chemically bonded key atoms of different elements. Compounds have to be different elements. I'm not crossing that out. I'm emphasizing. They have unique properties compared to their elements. Elements can be made of atoms or molecules. And two of the same atom bonded together are called diatomic. Okay, so did you do this? I know this is kind of long and I was talking a lot, but a lot of information on here. All right, make sure these are defined in your notes. All of these. All right, put them in there. Enjoy it, live it, love it, learn it. We love chem. Peace out. Oh, look, one big objective. Hopefully there's things you can think of for this objective. Peace out again from Harbs.